Yo, welcome back to my organic chemistry video. I apologize in advance if it sounds like there's a jet in the background. That is just my air conditioner, but it should go away here soon. So today I thought we'd be talking about electrophilicity. So what exactly is electrophilicity? Well, electrophilicity is basically just reactivity. The more electrophilic something is, the more reactive it is. So how can you think of electrophilicity to actually tackle some problems on an exam? Well, the best way to figure out what the most electrophilic portion of a molecule is, or what the most electrophilic molecule is to think of electrophilicity as the opposite of stability. Now, what do I mean by that? Well, something that's more stable is less likely to be reactive. If it's less likely to be reactive, it's less electrophilic. Something that's less stable is more likely to be reactive. If it's more reactive, it's more likely to be the better electrophile. So I've actually devised a little chart down here to actually help you with this concept. So let's think of it this way. Think of what stabilizes a positive charge on a molecule. Well, when dealing with carbocations, we know that tertiary is more stable than secondary, which is more stable than primary, which is more stable than methyl. So what makes the better electrophile is actually on the right here, and that's the opposite of this concept. So methyl, since it's less stable, is a better electrophile than a primary carbocation, which is a better electrophile than a secondary carbocation, which is a better electrophile than a tertiary carbocation. And I'm going to label this electrophiles so you guys actually understand and don't get these two confused. So the next thing that stabilizes a positive charge is the more resonance a molecule has, the more stable it is. So when we think of electrophilicity, what makes that less stable would be less resonance. So the less resonance a molecule has, the better electrophile it is. The next thing that stabilizes a positive charge is electron donating groups. So the more electron donating groups you have, the more stable the positive charge on the molecule. So what's that mean for electrophilicity? The more electron withdrawing groups, or the less electron donating groups you have on a molecule, the less stable that molecule is and the more reactive it is, meaning the better the electrophile it is. So the final thing you need to know for stabilizing a positive charge is that a positive charge on nitrogen is more stable than a positive charge on oxygen, which is more stable than a positive charge on carbon. So what's the opposite of that? Well, the opposite of that would be carbon with a positive charge is a better electrophile than oxygen with a positive charge, and that's better than a nitrogen with a positive charge. So it goes carbon's the best electrophile, then oxygen, and then nitrogen. And that's how you think of it. So I pose a little question here to get you thinking in this mindset. Out of these two spots, which one do you think is the most electrophilic carbon? Well, let's think of this in terms of either which one's less stable or which one's most electron deficient. We know this is an electron withdrawing group, and we know this is an electron withdrawing group. So we know that when resonance occurs here, it's making this portion of the carbon very electron deficient. However, we also have resonance that can go this way. So you have two electron withdrawing groups taking electrons from this carbon right here. That's making that positive charge very unstable and very electron deficient. Now this carbon right here only has one electron withdrawing group taking electrons away from it. So it is more stable than this carbon. So since this carbon is less stable, this carbon is your better electrophile. So another way to think of this. Let's just do this real quick. Which of these would be the better electrophile? This is the better electrophile because it's less stable than a tertiary carbocation. It has less inductive, where it's actually called hyperconjugation from these carbons, donate electrons to this positive carbon, or positive carbocation. Here, you have three carbons donating into this carbocation. Three basically electron donating groups donating into that carbocation, making that more stable. For the secondary, you only have two carbons donating into that carbocation, so it's less stable, more reactive, and in terms, a better electrophile. So let's do some practice now. So thinking of the first two molecules at the top, which one do you think would be the most electrophilic? Well, once again, let's think of this as which one's less stable. This one has more resonance. This one has less resonance. So more resonance makes a more stable carbocation. So since this one has less resonance, it's less stable, and it's the better electrophile. Moving on to the next one. Here we have two positive charges, and we have two oxygens. However, if you notice, with resonance, we can actually resonate this charge here, and then you could resonate again with the lone pair on the oxygen, actually putting the positive charge on the oxygen. Now the molecule on the right, when we resonate here, we would get a positive charge here, and then we can't resonate that anywhere else. So we have two carbons here with positive charge, and we have two carbons and an oxygen with a positive charge. So technically, two carbons with an oxygen with a positive charge is much more stable than two carbons with a positive charge. So since this is more stable, this is less stable, we in terms know that this is the better electrophile. So moving on, we have two benzene rings, and they each have a primary carbocation on them, and one has an electron donating group and one has an electron withdrawing group. So this is your electron donating group, and this is your electron withdrawing group. Now we know that electron withdrawing groups make carbocations less stable. And we know that electron donating groups make the carbocation more stable. So once again, since this is more stable, that's not the one we want for our electrophile. We want the less stable molecule, because less stable, more reactive. We would then go with this molecule. So I kind of hope that helps. I know it's kind of quick, but there's not too much to this. Just think the less stable the carbocation, the better the electrophile, because something that's less stable is more likely to be reactive because it wants to get to a more stable state. So I hope you guys are staying frosty, staying healthy, and you guys also have a wonderful night.